So final update for now. This is a byte that I'm sending from my Arduino Nano to the motor, and this is a byte that is coming from the motor. So after receiving it, I send back the status of the push buttons. And so here I have two cranks to simulate the torque. Here the torque sensor is for now not active in this code. So this is only emulating here the display. And so here you need, I have 680 kilo ohm from the yellow pin to the ground pin, that's green. And with a 36 volt motors, another guy needed 250 kilo ohm to get the motor controller on. And then only a plus and minus and one pin for this signal. That's because it's one line and both the communications in both directions go over one signal. And I completely rewrote the code. No serial control library, simply two interrupts. The first interrupt detecting the slope down, and then another interrupt that's every bit, every, don't know, 19,200 baud, and then I simply read the status, the bytes, the bits, and afterwards I send the bits. Now the motor is turned off, and here you can see the blinking LED because I could not read any assist mode. And so I now turn off the motor, turn it on again. Then you can here see the second bit, that's the assist mode that the motor has right now. And here that's, so after I've detected it's 1, 2, 3, that's the highest assist mode. If I now go to the mid assist mode, then you might have seen here a little change. For tenths of a second I sent a button push, and here this should have changed, and now it's only 2 times the LED. If I go down again, as you see here, the bit has changed position, and now it's only one blinking. That's the code of my my Arduino code. I could put it on GitHub, so leave a comment. I have also the code for a switch button, so off, on, no, on, off, on. So the on and the on pins going down to ground, and so I can simply have two pins for constant assist mode set, because here you need push buttons, but it's easier to have a switch, and then you would not really need to see the LED blinking because you know the position of the switch. What's a bit strange here, you see now it's the first 4 bit is 1000. Usually it was 1100, and I use this 1100 as error checking. But don't know why this motor now decided to set a 1000, and I would really like to have the motor bits containing a status if the motor is running or not, because here this resistance, by incidence, I have about 4.8 volt, and this decreases if also the battery voltage decreases. So the voltage from ground to this turn on resistance could be read by analog input and then used as a battery indicator. But only if the motor is not running, because when the motor is running, the battery voltage does not really say anything about the battery, what's left in the battery. But there could be, let's say the switch button could be a short switch and back, then this could be a signal that the voltage here is really taken into account, and then the LED blinking the battery voltage. So there still could be things that could be done, but I also ordered a ESP32 with a color TFT display on it, and then that would really be with the torque sensor and even the speed sensor, everything controlled and read by the ESP32. But this is also very nice. You see it's €1.70, so less than $2. And this can fully control the motor. So now are we in the lowest mode? Yes. So I now put some torque on the motor, and you can see how here if this changes, because it really would be nice if it changed, but I haven't seen yet any change here. So a bit of torque. Yes, now it's okay. So maybe you have already seen, but I will have a look when I stop this video, which I do now because I'm through. And so, as I said, code is, it's okay. I needed to change a bit, and also the parity bit, and so I really don't know what is the perfect one. And I might completely rewrite the code again, so I could put an interrupt on the falling slope and on a rising slope, and then simply put the microseconds in an array, and then another timer interrupt. So only let's say 10 milliseconds, and so after that then calculates the distance between the slopes to calculate the bits, and then well, send the output by. That would be more safe, because I don't really know the baud rate of the signal, and so if I simply measure the microseconds. But the guy that I wrote the code for, he seems to be very happy, so this is already working. Okay. Bye bye.